What's this equation? Wow.
This is a library.
Something about the
This is a library.
CO2 STP.
Stop. Okay. Help him.
Can you help me, sir? Since you seem to know everything.
This is already pounds.
I need to know this equation at STP.
This isn't a friggin' equation. This is what you're writing.
15 grams nitrogen.
Well, what is the mass of a mole of nitrogen? Do you know?
I think it's 44.01.
Oh, there you go. That's completely wrong. It's 14. Fool.
Alright. God, this freaking class.
Now, class, stoichiometry is the study of
I want to
chemical
go back to
equations,
sleep.
how to balance them, and how to
Yo,
extrapolate different
boss.
data
Get up.
Whoa!
from the...
Jeez, man.
Mr. Gross and
That's a
Mr.
pretty good
DeRosa, are
nap
you
right
paying
there.
attention at all?
Yeah, sure we are.
You really? No, I don't think so.
Well, to be completely honest, no. This is the worst, most boring lesson you have ever taught in this class.
So, what could we do to make it not boring?
Make it fun.
And?
How?
Are you challenging my method of teaching? Are you?
No, I'm just asking that we
Alright,
might have
alright.
a little bit of fun
So
in
we
this
can
class
do
for
an
once.
experiment. Is that a good idea? We can do an experiment.
Anything's better than this, sir. So.
Alright. Very well, we'll do an experiment.
Right here, we are about to start the experiment. We have the sodium bicarbonate inside the bottle with the funnel for putting in 125 milliliters of water.
This is going to be very exciting. We're going to create CO2 gas. Alright, it's got to be all at once, bro.
Funnel's taking a while for it to go in. Alright, throw that on. Need to do it quickly to make sure none of it escapes.
And here we have the CO2 gas just filling up. Now, the reason we're collecting the CO2 gas is to demonstrate the law of conservation of matter.
Make sure the products are equal to the reactants. And it could take a while, and it will slow down.
So we're going to keep you waiting for a while. See, the sodium bicarbonate and citric acid is just reacting now. Now, the only real source of error that could cause this to not obey the law of conservation of mass is when I remove this balloon. If there's extra CO2 in the gas in this bottle, that will escape.
And you can just hear some of it had to escape.
And some of it escaped. And we can actually prove that this is CO2 by seeing if it extinguishes fire, because fire needs oxygen to continue.
Perfect. Alright, right here we have all of our masses before the reaction. As you can see, we had 125 grams of water, or 125 milliliters, and then if we add that to the sodium bicarbonate, or the Alka-Seltzer, and then add that up also with the mass of the bottle, and the 2.71 gram balloon before we before there was a gas inside of it, and that came to a grand total of 334.36 grams. And then we completed the experiment, and we dropped the sodium bicarbonate. We dropped the water on the sodium bicarbonate, and yeah, the 3.62 grams of the balloon, and that would be right here after the reaction. And we had 134 grams of water in Alka-Seltzer, and that was the water inside of the beaker after. And yeah, of course, the 195 gram mass of the bottle, which we started with, and that goes to grand total of 332.62. So as you can see, this didn't completely obey the law of conservation mass, because unfortunately, when we were tying the balloon up, we lost definitely some weight there, as you could hear the hissing in the video. Also, while transferring waters, it definitely, we could have lost some weight, so yeah, that's the experiment. As you can see at the top, we have our balanced equation from the experiment: 3NaHCO3 plus 1C6H8O7, and then you're adding H2O there to produce 1C6H5NA3O7 plus 3CO2, 3H2O. And now this is completely balanced, so we are right here trying to solve a stoichiometry problem. How many liters an STP of CO2 is produced if we have 60 grams of sodium bicarbonate that reacts with the citric acid. So we started off, yeah, that's a given, 60 grams of NaHCO3, and then 1 mole of this is 72 grams is NaHCO3. And then this produces a 1-to-1 ratio, as you can see at the top with the CO2. It's a 3-to-3, but that reduces immediately down to 1-to-1. And then when you're trying to convert something into liters, you have to multiply it by 22.4 over 1 moles. You can see right here that the NaHCO3s cancel out like that, and the CO2s will cancel out like that, and these cancel out like this. So you are left with a grand total of liters of your CO2. And if we punch some numbers on
Houston,
that one,
punch the numbers.
we got 18.67 rounded. And this is the amount of liters that would be produced.
Hey class, remember this guy? Yeah, this guy was my professor as an overgraduate at Princeton University. Now, this guy, his real name being Cyrus Ernst, was a professor at Princeton who taught stoichiometry. Now, tragically, or not so tragically, he died after a croquet match in England. So this guy went bye-bye, along with his cranberry juice and everything else that defined him as a person. Now, he did have a few valuable contributions to stoichiometry. Most notably, go big or go home, stoichiometry. And so, but the biggest problem with this guy is that he didn't think that everybody could do stoichiometry. He thought stoichiometry was only for the rich or the famous, or just those who were wealthier than you or were smarter than you. And our mission, Brian and I, is to teach stoichiometry to everyday kids like you and me.